So now we want to use all those laws together to expand them into their individual logarithms of x, y, and z if those variables actually exist within the question. So here we have log base 6, x over y. Well, I've got a division here, so that means I can split apart my log into log base 6 and then x minus log base 6 of y. So now it's written into its individual logarithms of x and y. Okay, let's look at the next one. This one you have to go back actually possibly to grade 10. You learn this, where a square root is actually can be rewritten as to the exponent of 1/2. Now why that's important then is because we can take this 1/2 and put it to the front of our log. So I get 1/2 log base 5, and then we have x times y. Finally, I can split apart this x and this y because it's a multiplication. So it becomes 1/2 log 5, and then we have x. Now it is important that this coefficient actually stays with both logs. So it's going to be plus 1/2 log base 5 of y. Now the reason why is I could have done this a little bit different from this point. Had I said, hey, this is 1/2 and then put brackets, well, log base 5x, and I'm just taking apart using the product law here, and then plus log base 5 of y, well, then I'd have to actually distribute the 1/2 to each of these, and I would end up right here anyway. All right, moving to the next one then. So here we have a division, base 3. So I'm going to use my quotient law. So I'm going to go log base 3 of 9, and it's going to be subtraction because it's division. So minus log base 3 of x squared. We're almost done. We want this x to be by itself, so I'm going to take that 2 in our power law. So we got log base 3 of 9 minus 2 becomes the coefficient. So log base 3 of x. And for our final question, so we have log base 7 of x to the power of 5 times y all over the square root of z. Now you got to remember there is some brackets here. We don't write them, but they're there. And for that reason, I'm going to get rid of this division first inside the logarithm. So I'll rewrite this as log base 7 and keep the numerator as x to the power of 5 times y. Because it's division, it becomes subtraction. So log base 7 of square root of z. Now for this first logarithm then, there's still a multiplication between these x and the y. So I'm going to make that addition of 2 logs. So we're going to go log 7 x to the power of 5 plus log y. Now for the second part, or the second log, the square root of z, well, that can be written using our flower power. So we've got a power of 1 and a root of 2, so 1/2. We're almost done. Now we need to make all of these exponents become the coefficients. So this 5 is going to go to this front of this log, and this 1/2 is going to go to the front of the log as well. So it's going to become 5 log base 7 of x plus log y minus 1/2 log 7 of z. So one more time, and after we've expanded, now we want to actually simplify, and we're going to, in this case, evaluate each logarithm. Now it might not look like I can do any simplification here, but if I actually expand this using the product law, so it'll become log 3 9 plus log base 3, and I'll turn this 3 into a 1/2 right away, the square root into a 1/2. Now again, it doesn't look like we can do anything, but there is the law where if the base of our log is the same as the base of what's inside of here, then it's going to become what the exponent is. So 9 can actually be rewritten as 3 squared. And then over here, it's already written that way, where we have the base and the base are the same. Now the answers for both of these become what the exponent is. So we have an exponent of 2 there, and here we have an exponent of 1/2. So then 2 plus 1/2 is 5.5, or 5 over 2. Now, our second one is a little bit different. We have something that's already been expanded, and there's no way that I can turn, like, for instance, 4, write it as a base of 5, or at least not easily. So we're going to do this one a little bit differently in that I'm actually going to go the other way. I'm going to simplify these or make them into 1. So here we've got a subtraction between these logs. So I'm going to go log base 5, and the bases are the same. So 1000 divided by 4 is 250. And then minus log 5 of 2. We'll do it one more time. So then 250 divided by 2. So we get log base 5 of 125. Well, 125, I actually can write that as a base 5. It's 5 cubed. So one more time, we've got the base of our log and the base of our power the same. So our exponent is the answer. So we get an answer of 3.